Determine the equation of the circle in standard form. The equation of a circle in standard form is the square of x minus h plus the square of y minus k equals r squared, where the center is the point h comma k and r is the radius. Analyzing the circle on the left, notice the center is the origin, where the coordinates are 0, 0. This indicates that both h and k are equal to 0. And now we need to determine the radius. To determine the radius, we need to determine the distance from the center to a point on the circle. It's important that we do select a point on the circle, and therefore we'll use one of the two given points. The radius is the distance from the point 0, 0 to the point 5, 5. Notice on the graph it does appear as if 0, -7 would be a point on the circle, as well as 0, -7. But that's not actually true. The radius is not equal to 7. To determine the radius r, we can use the distance formula, or we can use the Pythagorean theorem. Recall the distance formula is derived from the Pythagorean theorem. In this video, I'll show how to find the radius r as well as r squared using both methods. Let's begin by using the distance formula. When using the distance formula, we'll let x1, y1 be the origin, and x2, y2 be the point 5, 5. And notice the distance d is really r. So using the distance formula, we have the radius r equals the square root of the square of x2 minus x1 is the square of 5 minus 0, plus the square of y2 minus y1 is also the square of 5 minus 0. Simplifying, we have r equals the square root of the sum of 5 squared and 5 squared. 5 squared equals 25. 25 plus 25 is equal to 50. R equals the square root of 50. We do not have to simplify the square root of 50 if we're only looking for the equation of the circle, because notice the equation calls for r squared. But if we are asked to state the radius, we should simplify the square root of 50. Recall 50 is equal to 25 times 2, where 25 is a perfect square. The square root of 25 is equal to 5. R is equal to 5 square root 2. But again, there's no need to simplify this if we only need the equation, because the equation calls for r squared. And notice r squared is equal to the square of the square root of 50, which equals 50. And now let's also show how we can determine r and r squared using the Pythagorean theorem. To use the Pythagorean theorem, we form a right triangle where the radius is the hypotenuse, and because the center is 0, 0, and we're using the point 5, 5, notice the horizontal leg of the right triangle would have a length of 5 units, and so would the vertical leg. So we can label this leg 5 and this leg 5, meaning both a and b in the Pythagorean theorem are equal to 5. And the hypotenuse c is really r, the radius. Using the Pythagorean theorem, we have r squared equals the square of 5 plus the square of 5, giving us r squared equals 50. Again, if we're looking for the equation of the circle, we could stop here, because we only need r squared for the equation. If we want to determine r, though, we would take the square root, or principal square root, of both sides of the equation, which, as we expect, gives us r equals the square root of 50, which equals 5 square root 2. Now that we know r squared equals 50, and both h and k are 0, we have the information we need to write the equation. The equation of the circle in standard form is the square of x minus h, which in our case is the square of x minus 0, plus the square of y minus k, which in our case is the square of y minus 0, equals r squared, which in our case we know equals 50. Simplifying, we have x squared plus y squared equals 50. I hope you found this helpful.